So we can't hear you. So we are unable to hear you.
Okay. Mansa, can you hear me now?
Yes, sir.
Okay, great. Thank you. So let me come back here. So there you go. Okay, great. Thank you, guys. Sorry about the delay. I just needed to reconnect and things like that. So let's go ahead and get started without much. Today, I'm going to be covering slightly advanced topics. We're going to dig deep into the language of AI professionals or data scientists that is generally used a lot and things like that. Slightly advanced topics. So please be ready to accept the complexity and also accept a little bit of uh, complex terms and things like that, guys. Okay, let's get started here. There is machine learning. If you recall, we're trying to teach the machines to solve problems. We give the data. How we do for humans learn intelligence, whereas machines learn from data is a mantra. Okay, generally what we do is we build the models. That's what we'll do. We'll try to do. We've been already doing it. We will try to build, and then we do we build a model. We want to when we want to make a prediction, we will build a model. Many times it is not easy, it is complex, it is super complex. It is not possible for humans to make many decisions. So that is where we're taking the help of the machines. And we try to build multiple models. Once we build the multiple models, what we try to do is we try to take the best model which gives us the highest accuracy. In other words, the model which seems to be giving us a lot of predictions correctly is what it is. And what is that? That is what is meant by evaluating the performance. There are a few measures, few metrics. These are slightly advanced topics, but stick with me and simplified. We'll try to understand, guys. One of them is accuracy. What is accuracy means? Imagine there are, let's build a model which is predicting if India is going to win a match or not. And now we are making predictions. Say in the last 10 matches, the model has predicted 8 of them of the 10 matches. Accuracy is 80%. Okay, what is that? That is classification. What is a classification? Let's say here, classification means you're trying to predict a yes kind of scenario, whether it win or not. What is that? That is a yes or no. So that is referred as a classification. Imagine you want to predict what score player is going to score. Then what is that? That's a numeric. That is called a regression. Okay. In other words, The score is a numeric value. If you want to predict the house price, well, it's actually $600,000. But let's say our model is to be 400,000 or 599. Of them are slightly from the actual. So they're not exactly 1,000, but the second one is slightly. The second one is much more to the actual value. So what is not classification? This is called regression. What we do here, we do not generally refer it as okay. Here, what we'll do is we'll try to focus a little bit more on the accuracy to understand a few terms. Performance measures. We build multiple models and we try to understand which one is better. In the world of classification, imagine we are building a model which is going to predict whether India is going to win or not. Okay, what is that? That's yes or no. That's what we are saying category. Category means textual data. What do? We have accuracy, which is just the plain straightforward accuracy. Let's say out of 10 matches, India our model predicted 8 of them correctly. The accuracy is 80%. But there is something called precision. There is something called recall. These are advanced ways of understanding whether our model is working correctly or not. Okay, then we have F, beta measure, and ROC and AUC. This is a slightly graphical way of understanding some of these aspects, and we'll see, guys. Okay, we'll not go much into regression, but we'll discuss more about classification, guys. In the world of regression, we go by error. Error is the difference between the actual value. Imagine we are predicting Sachin is going to score 100 runs, but let's say he actually scored 80 runs. So the difference between 100 and 80 is what is error. The difference between the actual score and the predicted score is what is error. So generally in a world of regression, we go by error. And let's see what we have here, guys. Here is another example. Imagine we have a group of shoes and we want to predict whether it's a Nike shoe or not. We built a model, we took some data, we built a model which it is going to predict whether it's a Nike or whether it's not Nike. What is that? That's a yes or no. What is that? That's a classification problem. In the world of classification, we talk about something called a confusion matrix. This is how a confusion matrix will look like, guys. Okay, so at a slightly high level, if we dig deep into this one, what we have here is these are the actual predictions. These are the actual values in the column, and this is the predicted values. This can be read as P hat or P bar. This can be read as N hat or N bar. What is P? P is the actual value. Actual number of positives, actual number of negatives, yes or no. So that's a yes, this is a no, that's a yes, that's a no, but these are predicted values. So in a moment, we'll try to dig a little bit deep into them. Then we have the terms called true positives, false negative, false positive, true negatives. This is the language of the data scientists. This is the language of the AI professionals and things like that, guys. So let's try to dig a little bit deep and try to understand. So here is true, one view of true positives. Predict Nike shoe as Nike. Imagine we have taken a few shoes and somebody, let's say we have taken, let's take an example here. Let's take, how about Ashok? Ashok, we have shown him a shoe and let's say it's Nike shoe. Okay, somehow he is using some kind of logic and he's saying this is Nike shoe. What's happening is it's true positive. What is true positive? We are saying, let me see, here Nike shoe, and let's say actually a Nike shoe, and let's take this. This is actually a Nike shoe, and what we are predicting. Let's come here, take this one. Let's put here. This is Ashok, and what he's doing is he's predicting as a Nike shoe. Okay, so what do we do? Well, come here, take a look at this. What is happening is we are predicting. So it's a Nike shoe. We'll call this as yes. This is yes, and this is no. This is not a Nike, and we'll call this as a yes here. We'll call this as a no. And let's take a Nike shoe. Here's a Nike shoe. So we have shown the shoe to Ashok, and he says, yes, this is a Nike. So what is it? Let's say this is actually a Nike, and what he's doing is we're predicting. Let's come here, which is this. He's predicting as yes. He's predicting as yes. So what is yes? Yes is positive. Okay, in a machine learning world, we can translate yes into true or positive. So what we are doing is we are predicting. What we are predicting is a positive. Okay, in other words, we're positive, and what is it? It is actually a positive, or it is. In other words, let me put it like this, guys. It is we are predicting as yes. What you will put a yes. We're predicting as yes, and what is it? It is actually a yes. So what is that? Our prediction is true. What is that? That is true. What you're predicting, we're predicting as yes, which is a positive. Yes means it's a positive. And what is happening? Our prediction is correct. What is that? So you put a true, that is called true positive. Predicting Nike shoe as a Nike. That is one way to think of it, guys. Okay, if I do a little bit of cleanup here, let's say a bit of this, then let's one more time. False positives. What we are doing is we are saying we're non-Nike. Let's say it's a right shoe. But now what's happening? A shoe also predicting a Reebok shoe as a Nike. What is that? That's a wrong thing. What is happening is, let's say, we will say, translate that and say, he's predicting it as Nike. This is false positive is here. This one, we are looking at this one. He's predicting as Nike means, yes. You show him a Reebok shoe, and saying yes. What is yes? Yes means it is, yes means true, true means it is positive. It is actually not a Nike, it is a Reebok. So what is prediction is wrong. What is that? That is false. What is referred as false positive. If you're predicting a Reebok as a Nike, we're calling it as false positive. What is positive? You are as Nike, which means yes. One more time. Yes. But what is it? It is actually not a Nike Reebok. That is positive, guys. Okay, let me see. Let me do a little bit of cleanup. Let me come back. Everybody is here so far with me, guys? Yes. Okay, then let's go to another one, which is false negative. What is false negative? Now we're predicting Nike, non-Nike, which means we're predicting as Nike as Reebok. So this is a Nike shoes. What is happening? Predicting as non-Nike, we are predicting as Reebok, which means what we are doing is it is actually Nike. It is actually a yes. It's actually a Nike, but what we are predicting is a no. What is a no? No can be translated to a negative. And what is happening is our prediction is wrong. Our prediction is wrong. So what is that? We're putting a false there. What is that? That is negative. What you're predicting is a no. No is a negative. What's happening? Our prediction is wrong. So we say it's false negative. Okay. Then come to predict non-Nike, non-Nike Reebok. And you're saying, hey, that's a Reebok. That could be Adidas or Puma also. In other words, in short, you're saying this is not Nike. So in other words, what you're doing is you're predicting as not. Not means no. A little bit of cleanup here. So we are predicting as, what do? You put negative here. And our prediction is true. So what is that? That is true negative. Okay. These are some terms to be kept in mind. As I said, slightly confusing. What is this? This is confusion matrix. Confusion matrix is a group of terms. This kind of terms. This is a language of a data professional machine learning engineer. This slightly advanced language, but that is what this guys. Okay, false. One more time. False negative is predicting as no. No means negative. Negative. So you put the negative there, and what's happening? Actually, yes. So what is you're predicting as a no? So your prediction is wrong. Wrong is false. What is that? That is false negative. Everybody with me, guys? Quick yes, please. One more time. So let's go one step forward and take a look at this. So accuracy. This is one of the ways how we can understand if our model, performing well or not, and things like that. test and things like that. Per the definition, we say choose. It is the number of samples predicted correctly. Oops, my bad. Choose. It's the number of samples. Take all the correct predictions and take the total. You may have made 10 cricket matches. We made predictions. What is 10? 10 is the total number of predictions, out of which only 8 of them are correct. Predicted correctly, so that will become the numerator. What is that? 80%. So imagine a scenario. Imagine we have a lot of shoes. We have close to 10,000 shoes. 10 of them are Nike. 9,999. 9,909 are non-Nike, which means they're Adidas, Puma, and things like that. Now, what we are trying to indicate here is accuracy is 99.9%. Number of correct predictions you take here. We have predicted, imagine a scenario, we have predicted everything which is not Nike as correctly. For the sake of simplicity, imagine there are just Reebok and Nike shoes, guys. 9,990 of them, they are Reebok. Let's say 10 of them, they are Nike. Now what is happening is accuracy means it is taking, you predicted, all these are correct. You predicted all the Reeboks as Reebok shoes. Okay, so you put that here, and what's happening? The total number of shoes is 10,000. So what's happening? This is 99.99%. But what is the problem here? The problem is we have not even predicted even one single Nike as Nike. We are predicting successfully all the Reeboks as Reebok, but we are not predicting any of the Nikes as Nike. What is that? That is a problem. But if you look at this number and you tell anybody, you have a model which is predicting 99.99%, well, what do we say? We say mathematically this is a very high value. But in real world, this kind of a scenario may not work. This kind of scenario will not be a good model. That is a problem with accuracy. Accuracy may be high, but it may not be. That means we may not be useful. What is this scenario? Let me do a little bit of cleanup here. We're taking bank data. Let's say we have transactions data where 9,990 of them are not fraud. But what do we have? 10 of them are fraud. And we built a model. Or predicting as if all these things, it predicts these non-fraud things as, but when it comes to what's happening, it is not even predicting one fraud correctly. In objective model is, this is more important. But mathematically, we have a very high value. Okay, so what is it? That's a problem with accuracy. Everybody with me, guys. Quick yes, please. That's a slightly tough one and a deep, but I'm trying to introduce you to some. Stick with me, guys. If you find it, just bear with me. So what do we do in such cases? We use what is called precision and recall also. Okay, precision of the shoes. Back to the shoes example, classified Nike. How many are actually Nike? So let's see what we have here. Precision is nothing but of the shoes classified as Nike. How many are actually Nike? So if you go back to the previous slide, what we are saying is 10 of them are Nike. But what is the problem? None of the shoes we have predicted correctly as Nike. All the Reebok as Reebok, but not the Nike as Nike. So here the precision is not there. It's not, we don't have precision. Recall is another metric of the shoes that are actually Nike. There are 10 of them which are actually Nike. How many are classified as Nike? It almost sounds similar to that, but let's go one step deep and take a look at this one. At the mathematical level, we can separate them into something like this. Precision. So here is precision. So what we are doing here is of the shoes classified. Oops, like here. Classified as Nike, how many are actually Nike is, what we are doing is precision is true positives, which is this one, plus false positives, which is this one. In other words, precision is taking this one, this column into consideration. Okay, this is one view of this confusion matrix. This table-like structure is referred as confusion matrix because it is slightly confusing. We'll call that as confusion matrix for the sake of simplicity. You think of that as a reason. But let's see, come back here. So what we are doing is we first take This column, true positives plus false positives, what is that? That is what this is. Number of shoes classified as Nike is this column. Then what we are doing is, we are taking this part of it. How many of them? Oops, one more time. Choose this one. We're taking this one, and what we're doing is, we take this one, we're going to take this, and we're going to, that is the true positive. So this one will become the numerator, this one will become the denominator. So let me see if I can scroll down here, or let me go back here. See if I scroll down a little bit here. That is recall. I think I have to go up here. Zoom it a little bit less. Okay, there you go. Let me take this one, snap it, put this here. So what's happening is true positives. So what is happening is, true positives is this one. What is true positive? We are predicting something as positive. Positive means yes. Yes means true. And what's happening? Our prediction is true. So we call that as true positives. Which means, how many of them are Nike, and we are predicting them as Nike. That is becoming the numerator. Okay, then say back here. So this is becoming the numerator. Take this one. This whole thing, true positives plus false positives, is becoming the denominator. The blue one is becoming the denominator, and this one is becoming the numerator. Is one way to think of it. Let's go one step ahead. See if I have another view of it. Okay, I have another view coming up in a moment. Before I go to that, let me also explain recall. Another advanced metric test. So what is recall? Recall is, choose this one. So of the shoes that are actually Nike, there were 10 of them that were actually Nike. How many are classified as Nike? So now what this is doing is, it's taking the true positives and the false negatives, which means directly we are taking how many of these, this row, how many of these are actually Nike, and how many so what is this? This is true positives and false negatives is becoming the denominator, and then true positives is this one, this is becoming the numerator at a mathematical level. Okay, but let's see, let's go one step forward. Come here. This is slightly at a theoretical level, or at a numeric level. Let's see if we can simplify this and understand it further, guys. So now here comes precision and recall. So what is happening in this scenario is, true positives is 0. True positives is 0 means, imagine we built a model. What is happening? If we go back to our model, which has 99.9% accuracy, what is happening there is, we are not predicting any of the Nike as Nike. So what is that? That is why our true positives is 0. Okay, and what is 10? 10 of them are false negative means, we predicted them as no. No means negative, and our prediction is false. Okay, so what does that mean? Well, 10 of them were actually Nike. So 10 of them were actually Nike. We are predicting as if they are not Nike. That is one more time. I'm probably repeating that again, maybe a third or a fourth time. So bear with me. So what is it? That's 10 of them. That's what the 10 value is doing. That's where we got. And true negatives is all the Reebok shoes. They are not Nike, and we are predicting them as Nike. So now what happens is, here, if you take the accuracy, it's mathematically high, but take a look at the precision. What is precision, guys? True positives is 0. And what is this one? True positives plus false positives is this one, and this one is also 0, which means it's not defined, it's infinity. Which means infinity is not interpretable. It is not useful, or it is not there. So indirectly, what is happening at a logical level, if we, in the real world, imagine we are working for Reebok or Nike. We built a model, and you're telling it, hey, you're working for Nike, and you have what, 10,000 shoes there, but not even one Nike. Your model is not even predicting one Nike correctly. What is that? Well, Nike cannot use that kind of a model for making a prediction. In other words, that's not a model that Nike can use. Okay, so what is that? That is where the precision is giving an indication. Precision is infinity means it is indirectly saying, hey guys, something is wrong with your model, is one way to think of it. Now let's translate the recall. Let's come back here. Here's the recall. Take a look at recall. Recall also true positives is ending up the numerator. And what is this? That is ending up 0. What is it? Precision is uninterpretable because it is infinity. What is happening? Recall is 0. What is that? Recall is also 0 means it's very low. Okay, even though accuracy is high, the precision is low. Or precision is infinity. It is not interpretable. We'll put it like that. Recall is low. So what does that mean? That means our model is not good. What is that? We're trying to understand the performance of the model. Everybody catching that, guys? Quick yes, please. This is a data scientist thinking. One more time, an AI thinking, a machine learning engineer thinking. These are the things you should decide. Do you like them? Do you don't like them? You want to work in this kind of environments thinking like this or not? Okay, is one way to think of it, guys. I'm not trying to scare you, but let's go one step ahead. So what is it? Recall is interpretable. It is low, but the accuracy is not really being useful here. So what do we do? Let's come here. So now what we are doing is, again, another advanced thing. Let's see, come here. Performance, let's put it here. Now what we are doing is we have another scenario. Let's choose this one. This time what is happening? 10 Nikes. 10 Nikes we predicted as they are Nike. Okay. What is false positive? We are predicting that as positive means we are predicting that as yes. And what is happening? Our prediction is wrong. So that's a false positive. So 9,990 of them are, we are predicting them as Nike, but they are actually Reebok. So what is happening is very, very few of them are correct here. Okay, imagine that's another scenario. So what do we do? In such a case, take a look at this. What will happen is we only predicted 10 of them correctly. So our accuracy is only 0.1%. That is very, very low accuracy. Now take a look at the precision. If we were to take up these values and substitute them, we are getting a very, very low precision. And the recall is very high. 1 means high. So this is a scenario where accuracy is very, very low. Accuracy is low, precision is low, and recall is very, very high. So what is it? Generally, for a model to work well, these three should be much balanced. They should be more balanced is one way to think of it. You cannot have. There are some scenarios where recall is more important than precision, and vice versa. But generally, in this scenario, what do we have? Well, recall is very high, but the precision is very low, accuracy is low. So what does that mean? Well, it could mean that the model is really not useful again. That's another way to understand it, guys. Let's see. So what is it? Precision and recall. If both of these, generally what we do is these both should be balanced. Balanced, they should be close to 1. If they are close to 1, then that means that's a good model. The model is working well is what it means, guys. Let's go one step ahead. Comparing the system. So here is another example. This one. So in a scenario, let's say we have a precision to be coming up to be 70%. Recall is coming to be low 60%. And here is another scenario where the precision is high, but the recall is low. So we can also use a F beta, an F score metric is what we can also do. So in some cases, take a look at this one. Cancer classification requires precision. In other words, if it's a healthcare scenario, even though the recall is low, if the precision is high, that is important. That is very important. So you might prefer that scenario. But in a scenario like Nike shoes, marketing and things like that, what might be more important? The reverse might be more important. You need the recall to be more important than the precision. What is that? Again, that will change from a domain to domain, from a story to a story based on the data that we are working. Sometimes you need high precision, sometimes you need high recall. Generally, having both of them high is a very good idea. If you're able to get them, it's a good model, guys. Everybody with so far? Quick yes, please. Okay, so let's dig a little bit deeper. Here's a model we built. You gave the data to an algorithm and you came up with the model. Here is the model. Let's see what is happening here. So let me move this one from here. Put this here. So now what is happening is, here is A. A, let us say for the sake of simplicity, is Nike shoes. There is one Nike shoes. We have, it is actually a Nike and we predicted as Nike. So here is something called input. Here is the answers. Answers is what we are predicting. Input is what it is actually. A, will call that as Nike. We predicted one of them. So we put a 1 there. Then let's go to the next step. Here is B. What is happening here is, come here, put this here. So let's choose this one. It is actually a B, but what we are doing is we're predicting as a D. That's what. It is actually a B, but we are predicting as a D, so this is a wrong prediction. Okay, so what is this? This is a scenario where you, just now what we have seen is we just saw this scenario, where we had only two choices, yes or no. But this is a multi-class classification. Okay, we have more than two choices, is what is happening here, guys. Let's go one step ahead. So a C is a C. In other words, let's say, come back here, put this here, and take this one. It is actually a C, and what we are doing, we're predicting as a C, so this is a good one. Our prediction is also a good one. That's a true, positive. Then take this one, this is a D. And what we are doing, we have taken two, let's say shoes, they're let's say Reebok. They're actually Reebok, and what we are doing, we're predicting as D, which means that is a correct prediction. So what is happening? Imagine we are taking a group of values like that and filling up a table. That is what is confusion matrix. How many of them we are actually Nike versus Reebok versus Adidas versus maybe Puma? These are the different kinds of shoes. How many of them we are predicting correctly? So what is this one? A. For the sake of simplicity, Nike, one Nike we predicted as Nike, one Reebok we predicted as Reebok, one Puma we predicted as Puma, two Adidas we predicted as Adidas. Okay, but if we do a little bit of cleanup, take a look at this one. This is actually, let us say, what is it? We'll call that as Reebok. What are we doing? We're predicting as Adidas. That's an error. In other words, another way to think of it is, if you look diagonally, these are all the correct predictions. The rest of them are all incorrect predictions, is what is happening. Oops, let me come back here. Where are you guys? Everybody with me, guys? T plus T. That should be, I think, a true positive, Ashok, if I'm getting you correctly. So let's see what else we have. Come here. So take a look at this. So in real world, we build multiple models like that. Now imagine a scenario. These are the two scenarios. After we built a couple of algorithms, we came up with these two models. Choose this one. So in this model, 10 Nikes were predicted as Nike. These are correct predictions. Correct predictions, correct predictions, correct ones. But notice some errors. These are errors, these are errors. These are errors. Errors are coming up. Now if you compare this one with this one, again, these are the correct predictions, rest of them are errors. What is this? You can manually look at like that. But what do? This is where we tend to use multiple measures again. So that's where the true positives and the true negatives are. False positives, false negatives are coming up. So let's see what that means. So take a look at this one. What is this? These are all the true positives. One more time. Another example. What we are saying is all these greens, the diagonals, are the true positives. It is actually A, and you're predicting as A. In other words, you're predicting as positive and your prediction is true. That is true positives. So one more time, the diagonal is always the true positives, guys. Next, come here. These are true negatives of A. In other words, let's say more precisely. So here we have these things going. These are the rows, and or in other words, those are the columns. These are the rows. So if you take 9 is true positives, but these are, what are they? What's happening here is one is actually, let's call it Nike. But what's happening? We're predicting as Reebok. What is that? That's a wrong prediction. That is what is going on. And then let's say this is Reebok. This is Puma. This is Adidas. What's happening? One of them, which is Reebok, we are actually predicting as Nike. But what is it? It's Reebok. Another one, 5. 5 of them, we're predicting as Nike. But what is it? It's actually Pumas. And the last one, we're predicting as Nike. But it is actually Adidas. So in other words, if I do a little bit of cleanup, these 3, we are predicting it as Nike, but they are not Nike. And what's happening in this row? In this row, these are actually Nike, but only one of them we are not predicting as Nike. Okay, what is this? These are the true negatives of A. The true negatives for A. Or in other words, more precisely what I'm trying to convey is, this is about Nike, this is about Nike. We're trying to focus on our predictions. Are they Nike or are they not Nike is what we are trying to focus. Let's go one step ahead. Take a look at this one. True negatives for D. So along those similar lines, what we have here, choose this one. 15 of them. 15 of them are actually, let's say, Adidas. And we are predicting them as Adidas. Okay. But if you take these things, they are actually Adidas. 4 plus 1 is 5. 5 are actually Adidas. What's happening? 4 of them we're predicting as Reebok and 1 of them we're predicting as maybe Puma. Okay, so in other words, if we do a little bit of cleanup, what we are trying to do is this one, and this one is what we are trying to focus on. Okay, next come here, incorrectly identified predictions for class A. So this is 1 and 5 is actually we're predicting as A, but they are B, C, and D. They're actually Nike, but we're predicting them as Reebok, Puma, and Adidas is what that is. Those are false positives. These are the false positives for B, false negatives for A, and so on. Okay, what is that? That is the terminology. That is what the terminology we're going to be throwing heavily in a real world and things like that, guys. Okay, so accuracy is calculated by the total number of correct predictions. What does that mean? Take a look at that. If you take all the green colored cells, they are the diagonal. You add them up, and then what do? You add them with the total number of values, total number of records which are there. That is, 80 records are there. What's happening? We're getting 0.78. That is a decent accuracy is what we can say. That this is how accuracy is getting calculated. Okay, then so if you come back here, what do we have? For the first model we're getting 80% accuracy. For the second model we're getting 72.5% accuracy. From an accuracy standpoint, the first model is a better model than a second model. In other words, let's see. Okay, I will not oversimplify it, guys, but the first model is better. Accuracy works well when the data is balanced. If there are equal number of A's, B's, C's, and D's, if there are sufficient number, they don't need to be equal. Imagine you have, let's say, 10. So take a look at this. Let's take another look at this one. So imagine we have a total of 10 Nikes. Okay, we have total of 10 Nikes. If you add 5 plus 3 is 8 plus 2 is 10. We have total of 10 Reeboks. 181 is 10. We have about 10 Puma. 9 plus 1 is 10. That's about 10 Adidas. What is this? This is called balanced data. You have 10, 10, 10, 10, 10 of each of them. In such a case, if your data is balanced, accuracy will do a good job. But many times in real world, your data may not be balanced. You have a group of shoes. What is happening? Well, let's come here. You may have a lot of shoes. You have, let's say, 100 plus 80 is 180, 190, 200. You have 200 Nike shoes. And what is it? 9 plus 1 is 10. 10 of them are Reebok. 10 of them are Puma. 10 of them are maybe Adidas. What is this? This is called imbalanced data. In real world, your data will not be balanced. In such case, accuracy will not be enough. Accuracy may be high, but it will not really do a good job in making prediction. Everybody with me, guys? Yes, theoretically, are you catching it? Okay, so if we take this one, what is happening here is the accuracy is also low. 54% is very, very low accuracy. But what is happening here is, guys, okay, if you look a little bit, okay, before I go into that aspect, accuracy is very low here, is very low. And if you come down here, accuracy is high for this model. Okay, so let's see what this means for a moment. Let's come here. Oops, pardon me. Sorry about that, guys. So let's see, come back here and see what we have. If we take, it looks like we have 200 Nike shoes. And, oops, one second. Sorry about that, guys. Back here. So we have totally 200 Nike shoes. What is happening is 100 of the Nike shoes, they're actually Nike and we predicted as Nike. That is a good one. 80 of them, what is happening? They are actually Nike. What are we doing? We're predicting them as B, means Reebok. 10 of them, they're actually Nike, but what are we doing? We're predicting them as Puma. 10 of them, they were predicting them as Adidas. So in other words, they're all actually Nikes. And what's happening? These are the three things where we are going wrong. So in other words, majority of them are Nike, and so among Nikes, what is happening? 100 is correct. Totally out of 200 Nikes, 100 of them were predicting correctly, but the remaining 100 were incorrectly predicting them. So from a Nike standpoint, we have about 50% we are doing a good job. Okay, but come back to the B, which is Reebok. What is happening? 9 of them, they are Reebok, we are predicting as B. Only one of them, which is Reebok, we're predicting that as Adidas. So indirectly, 90% of Reebok we did a good job, 80% of Puma we did a good job, 90% of Adidas we did a good job. In other words, more precisely, for Reebok, Puma, and Adidas we did a good job. Our accuracy is high, but it is only for the Nike our accuracy is low, is one way to think of it. Okay, then come down here. What's happening? The second model, second scenario, another scenario. One more time, this is also imbalanced data. There are a lot of Nike shoes. Okay, and what's happening is the Reebok and the Adidas and the Puma are also low again. So the accuracy is, even though the other things are coming, the accuracy is coming to be high. In other words, accuracy itself is not enough. That's what I'm trying to convey. Okay, so let's see what we can do. So take a look at this. In such case, this is called imbalanced scenario, imbalanced data. What can we do? We can use what is called an F1 score. Say choose this one. Here's F1 score. It is a good metric when data is imbalanced. So what is this? This is the recall. This becomes the precision. Given a class, prediction from the classifier, how likely is it to be correct? That is more from a literature standpoint. So let's see what is happening here, guys. Take a look at, again, this is the Nike shoes. Nike shoes, a lot of Nike shoes we are predicting correctly. Majority of these things is what we just looked at. So if we dig a little bit deep into it, F1 score is a harmonic mean. In other words, it's a mean of recall, it is a mean of precision. It's precision. It is a mean, more precisely it's harmonic mean. So harmonic mean is nothing but it at a literature level. Generally mean is at the center, harmonic mean is somewhere over here. At a literature level, it is have the harmonic mean, and the higher the recall. So notice if we come back here, at a literature level, the more the harmonic mean, it is away from the higher value. The more the precision, it is slightly away from the value. So what it is doing is, we say it is punishing, it is away from the extreme value from a literature standpoint, and below is the formula. So scroll down here. This is how we are calculating the harmonic mean. In other words, we can also use F1 score to understand if our model is doing well or not when we have imbalanced data. So let's see if this helps us. Here is precision of model 1. Precision of model 1 is coming to be 0.492, not a good one. That needs to be generally much higher, is what the precision is indicating. Okay, and those are again the true positives, false positives. Those are that is how, if you calculate, that is what is coming up to be. Then you have recall of model 1, it's coming to be 0.775. Average recall. So we are individually calculating the recall of A, B, C, D, Nike, Reebok, and so on, and then we are taking an average. That's how we're getting 0.775 at a numerical level, guys. Okay, so now if we calculate F1 score 0.601, what is this one? This is for model 1. For model 2, we are getting 0.342. So if you compare the F1 score, the model 1 seems to be better than the model 2, even though the accuracy is low. So just for the sake of discipline, back here, come back here. So what do? Even though the accuracy is low here and the accuracy is high here, what's happening is, let's say, choose this one. F1 score is higher here and F1 score is lower here. So what do we say? This model is a better model than this model. Okay, so in other words, when we build multiple models, this is how we keep thinking. We check from an accuracy standpoint. We also check from an F1 score standpoint. F1 score is internally looking at the precision. It is looking at the precision and the recall. Okay, guys, everybody with me? Quick yes. I think Vinod is saying he couldn't understand the concept, but that's acceptable, buddy. This is I'll take a little bit more time. You need an example, a few more examples and things like that for me to make you perfect or an expert in these concepts, as I said. So F1 score. So model 1 predicts well on multiple classification on imbalanced given data, and F1 score is a metric to quantify its performance. So in other words, when we have imbalanced data, F1 score is a better one than accuracy is what we are trying to convey. So one more time, just another quick look. These tables are called confusion matrix. What do we have here? Here we have a 4x4. This is multi-class. If you just have two of them, they are called binary classification. We have yes or no, not an ABCD and ABCD is what we don't have. So this is binary class because we have only two choices. Again, we're just saying, hey, so what is this? 50 plus 100, 60, 65, that's totally 165 out of them. And generally, what is this? We have, these are the correct predictions. And these are incorrect predictions. Our objective is always to keep these incorrect predictions as low as possible. And the correct predictions, for a good model, the correct predictions have to be as high as possible is one way to think of it, guys. So let's see what we are saying. There are two possible predicted classes, yes or no. If we were predicting the presence of a disease, so now I'm applying a healthcare scenario. Disease, we have taken a few patients and we have come up with how many of them. Imagine we built a model and our model is predicting a patient will get or a person will get a disease versus a person will not get disease. So what is happening? The classifier made a total of 165 predictions. 165 patients were being tested. Out of those 165, the classifier predicted 110 times. 110 times predicted yes as 110 times, no as 55 times, which means that 110 times as, oops, come back here. 110 times is this one. These are how many times it predicted as yes, and these are how many times it predicted as no. So in other words, what we are doing, guys, in a way, we are trying to understand the individual results, then we are trying to understand the rows. In a way, we are trying to tell something from the columns. Then what we are doing is we are trying to take this row and this value. Then we are trying to take this value and this one. What are we doing? From every aspect of it, we are trying to explain something. We are trying to tell a story. That is what we are doing. There's a lot of things we are talking from this one, guys. There's one more time. So if you take a look at this, accuracy is 0.91 for this one. Misclassification rate, notice it's 0.09 is nothing but the error rate. Okay, if you're 91% accurate means you're 9% error. That error is referred as error rate. True positive rate is also referred as sensitivity. So in a machine learning world, we call true positive rate as sensitivity or recall, and false positive rate, again, when it's actually no, how often does it predict as yes. Then true negative rate, that is referred as specificity, another term we'll be using a lot. Generally, this is the language of a data scientist. Then precision, we briefly looked at precision, and recall is nothing but the true positive rate or sensitivity, guys. Okay, so that is a touch of true positives versus false, true positives, false negative, true negative, and more precisely the diagonal. Let's say come here, shows this one. This diagonal is errors. This is called the type 1 error, this is called the type 2 error. In certain scenarios, type 1 error is more dangerous. In certain scenarios, type 2 error is more dangerous. So we need the specific values to be less. Again, we'll see if we can. So there's again a quick touch of the definitions from a healthcare standpoint. So let's see what we have. True positives, cases when classifier predicted true. Classifier predicted true. So I come here, predicted true, and the class was true. That is true positives, true negatives. when we predicted as false and it was false. False positives you predicted as true. True is positive, and what's happening? Your prediction is false. That becomes false positives. False negatives is your predict is false is negative, and your prediction is false, so that's becoming false negative. They don't have actually the disease, so I'm just trying to explain in terms of healthcare scenario. Again, a quick touch of that one, guys. Everybody with me so far, guys, about the terms? It was barking for generating some fun in the middle. Oh, okay, no problem, sorry about that. I get so involved, I forgot about the doggy and things like that, sorry about that. Yeah, I have a small puppy at home and things like that on a slightly lighter note, guys. They are just lovely pets, guys. They are God's special blessing. Those small little pets, they fill up the vacuum in our lives and things like that and so on, guys. Maybe some other time, guys. Okay, good. Thank you for bringing it up. I appreciate that. But let's see if we can get into a little bit of action here, guys. Let's say come here. See what we have here. Say put that here. Fasting blood sugar. And I think I'm an AP skill dev. Fasting blood sugar. That's what we looked at yesterday. So one more time. Looks like I may not be able to cover the complete thing, but let's start with a few imports and let's do a little bit of playing around. Here is heart disease, a similar data set that we have looked at yesterday. Not this one, I need to go here. Lambda functions, and let's see if I'm here. It's vision. Let's go here, say new. Okay, start with a few imports, give it a moment. Here is some data. We're going to read the heart disease. It is similar to what we have read yesterday. So there is age, sex is gender, it is chest pain, this is blood pressure I think, this is cholesterol, this is blood sugar, ECG, this is something related to heartbeat rate I think, and then we have exine probably related to exercise, and so on. Target is one means this guy got this heart disease, whether that's a heart attack, cardio or other kind of cardiovascular disease and so on. Zero means a particular patient or the guy who has been tested does not have is what it is. So it's 1 is a yes and 0 is no. So this is called a binary classification. Okay, you'll keep hearing. Most of the times you'll be coming across binary classification and things like that. If you recall, DF, read CSV, creates a data frame and head gives you the top 5 rows of all columns. Okay guys, then let's come back here. So we're going to just rename that as data. Shape will give you how many rows and columns are there totally. So we have 303 patients data, 14 columns is what we have. And then what do? We're just checking the unique values. We have done this yesterday, repeating some of the steps for sake of discipline. Generally follow this approach. So ages, that is probably numeric. If you're seeing a lot of values, these are probably numeric. Less than 2, 3, 4, maybe less than 10 and things like that, they are probably categorical. Categorical means limited number. They actually look like they are numeric values, but they are actually non-numeric. In other words, they are textual data. So that is again what we discussed yesterday. Then describe, if you remember, it will give us the basic statistics. So for age, you try to understand, hey, we have patients from minimum 29 years to 77 years on an average. It looks like 54 years is the average. Then gender, again, you try to understand the min. 0 is probably female, 1 is male. Mean may not be very useful. Chest pain, again, minimum is 0. Again, these are categorical values. So like that, you try to understand, get a feel of the min, mean, max, and standard deviation. And we'll try to verify if any of these are null values. So hit up null values. Now we see all of them as zeros. That means we do not have null values. Value count, it will tell you how many of them. So notice, out of the 303 patients, 165 patients have heart disease. 138 of them do not have heart disease. So that's like a balanced data. Imagine this was like this was like 165. And let's say this was only 38. That is imbalanced data. This is a balanced data scenario, is what it is. if there's a good proportion between our positive means those who have heart disease versus negative means who do not have it. So that is value count. Each value, how many it is, that is value count. Then we looked at a quick correlation. Let's say, come here, try to execute this. Data.core. Guilty. Oh, I think I'm missing some of the imports. Okay. Here we go. Copy this one. Import, backplot, and let's see. I'll just go and put this here. Wait a moment. Pardon me. Sorry about that. So let's see what is happening, guys. This is generally the process, the method, and the procedure that we mostly follow for a classification scenario, guys. Remember again, classification means a yes or no. You have to manually remember. If you go to cricket and I say bat is a bat, you ask me why you call bat a bat. Well, bat is a bat. Classification means if you're dealing with a scenario where you're predicting yes or no, that is referred as a classification. As simple as that, guys. So now if we come here, so let's say come here, take a snap of this. Roughly here is what is happening. So here is the target. If you notice, here is target. Target is our dependent variable. And what's happening is, as scrolling up, notice as the intensity of the color is becoming more and more red, what is happening is it's becoming a positive number, and we say the magnitude is increasing 0.4, 0.6, and so on, 0.8. So notice when we compare the target, this seems to be in slightly reddish, getting reddish. So what is this one? If you project this here, this is CP. What is CP? Chest pain. In other words, what it means is, as the chest pain is more, what's happening is there is heart attack happening. And if you think logically, if the patients or the people are having a lot of chest pain, then the risk of getting a heart attack is more. So that's a positive correlation there. If one is high, other is high. Then come to, let us say, what is this one? This is heartbeat rate. I think Thelalk. I think that is heartbeat rate. If your heartbeat rate is also high, what's happening is a lot of people who have, or in other words, if your heartbeat rate is also high, okay, assuming that is heartbeat rate, what's happening? A lot of people, they're also getting heart attack. Then look at the other red. This is the 0.35. Slope I don't know, so I will not be able to interpret it. But that is the story of the red colors. Then come to, as you're going down, the intensity of the blue color is increasing. So notice 0.44. What is the X line? Something related to exercise. If you're, let us say this is negatively correlated. So if I clean it up, notice that is negative. It's like inversely proportional. As one is more, other one is high. Very few patients, okay, or in other words, let's say a lot of people who are doing exercises, for the sake of simplicity, if you're doing a lot of exercises, very few people are getting majority of the people are not getting heart attack is what I'll translate it. There is a better way of explaining it. Okay, but that is an acceptable thing. That is not a perfect thing. So in other words, that is inversely, that is also negative. All this slightly, as it is getting more, as the intensity of the blue color is slightly increasing, that means they're negatively correlated. Everybody with me, guys? Quick yes, please. Okay, are you able to hear me fine? Shake. One more time, Ashok. Okay, thank you, guys. Looks like some guys. So generally what we do is we don't need all these things, but generally what you do, you need the target. And let's say if I do a cleanup, this is the one which is the most important thing. You try to understand, get a feel of the correlation. How your dependent variable is correlated with all these independent variables. Are they positive, are they negative, and things like that. If they're positive, then that variable is having a lot of influence on the dependent variable. So you try to select that variable. That is what you try to do it here, guys. Okay, so that is correlation. So that's what we are saying. Notice there is a positive correlation between chest pain and target. The greater the amount of the chest pain results in a greater chance of having heart disease. It's a typical angina. I think there is something that is probably a shoulder pain, that is a back pain, neck pain, head pain, and things like that. Asymptomatic is no symptoms. Negative correlation between exercise and our predictor, or in other words, our dependent variable. You do more exercise, you have less chances of getting a heart attack. Very few patients are there where they're doing more, or in other words, imagine a lot of patients, they are not exercising but they're getting a lot of heart pain or heart cardiovascular diseases, and we can logically understand. So notice this, when we exercise, take a look at this. When we exercise, our heart requires more blood, but narrowed arteries slow down blood flow, blood supply. Okay, so what is happening is, so that is, I think, something related to narrowed arteries, guys. That is what is the meaning of that. But pay plots, okay. So now what we'll do is, we have taken all the columns. A plot will only take continuous numeric data. On here, it's a similar thing. We've done it yesterday also. We're taking only the numeric columns. Give it a moment. That's taking longer. Okay, you generally try to understand. Do you have a positive correlation between any two variables versus negative correlation or a neutral correlation? You try to get a feel of it, and you also try to get a feel of the distribution, guys. I won't go too much into those aspects now, but let's come back here. Take a look at this. These are all, the target is one, means these are all the patients who have the heart disease. What's their age? Again, minimum 29 to 76, on average 52. And next, sex and CP, chest pain. So what are these? These are the characteristics of the patients, guys. Let's see, take a look at the blood. What is this? Blood pressure. Their minimum blood pressure is 94, maximum is 180, and what is this one? The average is 129. Okay, now let's come back here. Take a look at these guys who do not have the heart disease. For the sake of discipline, let's say put it here. Now what is happening? Their average seems to be, their blood pressure seems to be 134, whereas this one is 129. Not a lot of difference if you take the average, but take a look at this. The people who do not have blood pressure, they're fluctuating anywhere from 100 to 200, and the people who have heart disease, they're fluctuating. Their blood pressure is low, and it is 180. It's slightly low. There is some difference. You can take a single one. You can try to compare each one like that. Spend some time. You can try to understand the average cholesterol. Take a look at the cholesterol, 242 in the group of patients who have the heart disease, and 251. Not a lot of difference. But again, we may need a physician and things like that also to verify that at that level of detail. But ideally, we'll try to get a feel of is there a lot of difference here or not, and things like that, guys. So now take a look at this one. Here is positive patients, ST depression. Let's see what that looks like. We're taking one of the columns. So notice this one. There is something called ST depression. Is a column. In the positive patients, old peak. Okay, in the positive patients, the mean. So notice what we are doing. We're taking that column. We're calculating the mean. It is 0.58. What is positive patients? These are the patients with the heart disease. Their old peak, their depression is very low. Or I don't know exactly what that ST is, guys, but that is low. And take a look at this. This is high, negative. So which means there is a lot of difference. In the world of statistics, when you say there is no difference versus there is a difference, there is this concept of hypothesis testing emerging there. That's where we try to verify. So it looks like this is an important variable which will tell us. We can select this variable or a feature, we call that, to build a model. Okay, this is ST depression. Let's take a look at TALALC. So what are we saying? Take a look at this. Positive patients exhibit 1/3 the amount of ST depression induced by the exercise relative to rest. That's a formal literature. Let's take a look at TALALC. This is probably related to exercises. What do we have? In the negative, in the patients who do not have the heart disease, cardiovascular disease, the TALALC is low, and this is slightly high. So from a literature perspective, say patients cardiovascular disease have a heightened maximum heart rate. There you go, heart rate. Their heart rate is too high. If your heart rate is too high, that means there is a chance that you might get cardiovascular disease. Everybody catching the point, guys? Everybody, is that making sense? Are you with me? Okay. So next starts the modeling. So let me quickly go ahead and run the model here. I have only a few minutes here. Sorry about that. So if you recall, we discussed about these steps. We first separate the independent variables, that is dependent variables. Then we split or partition the data. And then we scale the data. Scaling the data is for removing the bias, guys. Again, I have explained earlier a little bit more in detail. So there's a logistic regression. We are fitting it. Fitting is where the algorithm does its mathematics. Then you predict, and here comes our report, our advanced report, which we've been talking the whole day today. So give it a moment. Okay, if you come here, there is a precision, there is a recall, there is F1 score. Since ours, and here is the accuracy. What are we getting? We're getting an accuracy of 74% accuracy. Because ours is a balanced data, we can go with accuracy. Notice the precision. Precision is not bad. They're all pretty good numbers, not too bad at all. So accuracy 74 means for every 100 patients, we are predicting 74 of them correctly is what it means. There are still chances of increasing. If we do go ahead and perform some data cleaning techniques, go dig a little bit more, try to do a little bit of feature engineering. If time permits, I will cover those topics maybe tomorrow or day after tomorrow, guys. So what is a classification report? What do you do generally as a data scientist? At the end, you look at this one, you also make sure these numbers are, imagine this was like 0.07, 0.01. Okay, that is very, very low. It is not a good model. And there's another way called an AUC, that's a graphical way of also choosing. So these are some of the metrics we discussed today, guys. Everybody with me, guys? Quick yes, please. It is referred as the classification score. F is mnemonic of precision and recall assure. That's what I was trying to explain today. Okay, so let's see, guys. So as I said, these are slightly advanced concepts, guys. I don't expect you to be perfect, but I'm trying to give you a picture, a view into these things. Tomorrow also I'll take you into a journey of few more advanced terms, such as bias and variance and those terms. And this is the thinking. This is the world of machine learning and AI, guys. These are the things which go around, and this is how we talk. This is our language and things like that. And this is what you need to learn. You need to be familiar if you want to go into the real world. People will be starting here. A senior data scientist may build a model. He is getting, these values. He will suddenly look. Imagine this was like 0.07. Imagine Ashok is a mid-level or a junior data scientist. He'll call them. No, not necessarily a junior data scientist, but generally they will call their team and say, guys, this is 0.07. We somehow need to increase the precision here. So what is up to you? You need to do some data cleaning, to dig a little bit deep, to execute some other techniques and things like that. That is generally. So even though it looks like this is the last step I'm trying to convey is, a senior data scientist may start here. He will quickly run this, he'll look at these values, and he will now call his team and say, guys, bump up these numbers. I want these to be in 90s or close to 1. Go ahead, play around with it and do whatever techniques you can and things like that, univariate analysis, bivariate analysis, multivariate analysis. There are many, tens and tens of such techniques, guys. We cannot cover everything in a very limited point of time, but hopefully you're getting an idea, guys. Fair enough, guys? Quick yes, please. Okay, so guys, for today I'll stop it here. For any non-technical questions, please try to reach out to Mansa and allow me to sign off here for today, guys. Thank you, Parmila. I appreciate that. You guys, I appreciate that sportsmanship there. And excellent, Thank you. I'll be sharing these things, guys. Okay, just give me a little bit of time. I will be sharing. And AML course will help you. Okay, will AI ML course will help you? AML course will not only help you, it will leave everybody. It will help everybody. Okay, guys, the whole world is trying to now use machine learning and deep learning, so definitely give a positive look at it, guys. I don't want to over motivate you or over exaggerate about that, but it is something when you are applying for a job. Okay, imagine you are my good friend. What I will tell you is, No matter where you take the training, you have that presence of machine learning, deep learning, natural language processing, computer vision on your resume, and then try for a job. Your chances will be more. As simple as it. You can take it anywhere. You should be able to understand these things, guys. Okay, so that is like a very personal recommendation, guys. Okay, we'll talk about sensitivity and specificity also try tomorrow, guys. Thank you again, guys. I'm signing off. You guys take care, stay safe, and keep learning. Thank you, and bye for now, guys.
Jashwant Kumar, you have asked the question that when will be the exam. So it will be on the end of the training, maybe this Friday or Saturday. Ask once again and we'll send it to your registered mail IDs. Exam, what kind of exam means? There will be an MCQs. Yes, it is planned for 30 days, but due to some issues, actually we wanted to wind up it by 18th. But in this training, all the topics will be covered as per the course. Please don't worry about the course. Yes, the training will be completed by this week. By the end of the training, we will share the material to your registered mail IDs. The whole content is available in the YouTube. All the recorded sessions are available there in the APSSDC YouTube channel. You will get the content from there. If you have any doubts, you can go to the respective session and you can clear your doubts. Thank you all.